Bainey, and we're going to take a look at, hey, what's up, Math 1? We're going to take, hello, this is Mr. Bainey. Hello, here we have lesson 20.3, SAS triangle congruence. You learned in 20.2 the very first triangle congruence theorem, which is ASA, and here is our second one. And you could probably guess what this means. SAS is side angle side. Compared to, in the last lesson, we had angle, side, angle. Now we say side angle side. We don't say angle side side or side side angle or anything like that. It's side angle side because the angle must be the included angle, or the angle that's in between these two parts. It's in between the two sides that we use for congruence. So what I mean by that is, if I go to one of these triangles here, I'll show you on the next page actually, what an included angle will look like, but it's going to work pretty much the same way as ASA, where we have the included side in that one. So definitely go back to watch 20.2 if you need a refresher on what included side means. Here on page 1017 is the statement of the SAS triangle congruence theorem. Go ahead and read that, but just to summarize, it's if two pairs of sides and the pair of included angles, if those are congruent, then the triangles are congruent. Remember that the triangles being congruent means that we can use CP/CTC because that tells us all 6 parts will now be congruent. Okay, that's mainly the whole purpose of wanting the two shapes to be congruent to each other. On top of page 1018 is a couple of, or not a couple, it's just one problem, one your turn for us to take a look at. So I want to see, are these two triangles, are they congruent? Let's explain our reasoning, or at least write down some statements to help us with that. So we know that angle D is congruent to angle G. Oops. I'm going to mark it on the picture too with color, just so you know what we're looking at here. We have side DE is congruent to side HG, right? We know they're congruent because their measures are equal. I'll mark that with one tick mark there. And 1.7 centimeters is on both DF and on JG. Okay. So when we look at the SAS theorem, right, we have 3 pairs of parts that are congruent. We do know this is 2.9 here, but we don't know that this is 2.9. So remember, don't just assume that this has to be 2.9, not quite yet. Right? Don't assume that you know these two angles, E and F, are congruent to H and J. Nothing like that, unless we have an actual theorem that helps us with that. So, is this enough? And we have 2 pairs of sides, right? We have 2 pairs of sides, and angle D and angle G actually happen to be the included angle in between the 2 sides. And one kind of nice way to tell, I'll show this very quickly and then I'll erase it, is that you notice on both DE and DF both share the letter D. So D is kind of like the vertex of those 2 sides, or not the vertex, but the intersecting point, the point in common. And then if you look at HG and JG, they both share G. And both D and G happen to be our included angle up here. All right, so that's how you know D is included in between the 2 sides we use, and G is included in between the 2 sides that we use on the other triangle. Okay. So these 2 are congruent. So let's write our congruent statement. Triangle DEF is congruent to, let's make sure we get our order correct here, GHJ. and they are congruent by SAS. Two pairs of sides, a pair of included angles. That's all we need. On the next page, 1019, looks like we only have one proof, and then we'll be done here. So number 4, we are given that side AB is congruent to side AD. I'm going to mark that in the picture. And angle 1 is congruent to angle 2. We want to prove that triangle BAC is congruent to triangle DAC. I'm going to be a little bit lazy here and write down that statement number 1 is the given. I'm not going to write down that whole statement, but we have two pairs of congruent parts, right? We have a pair of congruent sides, a pair of congruent angles. Keep in mind, we have two congruence theorems. ASA from the last lesson, SAS from this lesson. Your assignment problems could very well use both theorems, right? So you need to look out for both ASA and SAS. And it's going to get, tougher as we go along because we're going to add more. Remember that. So if we're going to use SAS, we can look for a pair of sides where the angle's included. If we're going to use ASA, we want to look for another pair of angles. So we just look at what has to be congruent. Both triangles looks like they share a side. They share this side right here, and that is side AC. AC from the top triangle has to be congruent to AC from the bottom triangle, and that is by reflexive property of congruence. So I want to mark that on the picture. Angle 1 is included in between the two sides AB and AC, and also it's included in between AC and AD, right? They all have that common point of point A. So since the angles are included in between the sides, we know that by, oops, I was about to write ASA. It's by SAS, the two triangles must be congruent. Right, and there you have it. Be sure to be updating your notes, your index cards with all of these definitions, these theorems. You're going to be using these a ton, and as you're doing as your assignment, if you're coming across words that you haven't heard of before, or you feel like there just isn't enough information. I know there is a problem that talks about a regular hexagon or some regular polygon, right? The word regular actually has a meaning in math that's different from regular English. A regular shape means that all of the sides are the same and all of the angles are the same as each other, right? Like a square. Think a square has 4 equal sides, all the same, and all angles are right angles, which means they're all the same as each other. So we would consider a square as a regular shape, or like an equilateral triangle as a regular shape, right? So that's just one very specific example of a definition you'll want to be aware of, and you'll actually want to remember unless you add that to your notes. So every time we come across something, just add it, because writing these proofs is already difficult enough, having to fill out all these details, let alone trying to memorize all these different definitions, properties, theorems, postulates, and all these things. So that's going to be it. Thanks so much for watching. I hope it was very helpful to you. Have a good day.